Here we go. Let's check how you did on 18 and then finish page 19. So the first one that you had to do, this is the bottom of page 18. You rolled a 6-sided dice twice. Find the probability that'd be even and then odd. So again, 6-sided dice. So 2, 4, and 6 are even. So it'd be 3 out of 6, which equals 1/2. Odd, 2 or 1, 3, 5. So 3 out of 6 is 1/2. 1 times 1 is 1, 2 times 2 is 4. Even if you didn't simplify it to be 1/2, you would have 3 over 6 times 3 over 6, and you would get 9 over 36, which simplifies to be 1/4. So if you don't see that it simplifies, when you do at the end, it'll be fine. Number 2, you have 5 cards. Each one has a different vowel on it. So A, E, I, O, U. So what's the probability first that you would have an A? So that would be 1 out of the 5. But now the A is gone and there are only 4 left. So what's the probability of getting an E? 1 out of 4. So 1 times 1 is 1, 5 times 4 is 20. Here you got some marbles. Don't lose your marbles, haha. So there's 6 marbles. There are 2 red, 3 green, 1 blue. You select 1 marble and then another without replacement. So this I wrote a little more so you could see my thinking here. So the probability that the first one would be red, there are 2 red out of the 6 total. 2 over 6 simplifies to be 1/3. If you simplify this as you go, it will actually obviously make the multiplication a little easier at the end. The blue, though, think about this. That red marble is now gone. Well, there were 6. That red marble is now gone. So there are only 5 marbles left. How many of those are blue? 1. So that's why the probability of getting blue second would be 1 out of 5. So then the probability of getting red was 1/3. Blue for the second would be 1/5. 1 times 1 is 1. 3 times 5 is 15. Here, you flip a coin 4 times. What's the probability that you would get tails, a heads, and then a tails? So 4 things happening. And so again, 4 things means you need 4 probabilities or 4 fractions. So probability of the first one's tails, 1/2. 1 tail out of your 2 outcomes. Next one tail, same thing, 1/2. Heads, there's only 1 heads out of the 2 options, so 1/2. And then tails, 1/2. 1 times 1 times 1 times 1 is 1. And then 2 times 2 is 4, times 2 is 8, times 2 is 16. So you should get 1 out of 16. Now let's look at page 19. Hopefully you did well on that. So page 19 is a tree diagram, and you're gonna have to do lots of tree diagrams with your genetics stuff next week. So cousin camp is going to last 1 more day. The cousins decide to continue, this should say flipping, sorry about that, flipping a coin to determine if they'll go swimming or have a water balloon fight. Complete the tree diagram below and answer the following questions. So on Friday, they could either go swimming or they could have a water balloon fight. Apparently, they could not do both, so one or the other. So doesn't matter which one they chose on Friday. On Saturday, they could still choose to go swimming, or they could have chosen to have a water balloon fight. Same thing. If they would have done a water balloon fight on Friday, it doesn't matter. They could do another one, or they could have gone swimming. And so it's like each day it's bringing its own choices. So then on Sunday, if they had gone swimming, Sunday they could have still gone swimming, or they could have done a water balloon fight. This one would say if they've gone swimming and then water balloon fight, well, then they could have either gone swimming on Sunday or they could have had a water balloon fight. Here, down here, if they would have had a water balloon fight, they could have gone swimming, or they could have had a water balloon fight. So it's like every time you add a day or like a level on, it breaks the tree into smaller pieces, and there are more outcomes that you're possibly going to have. Here, it's saying they had a water balloon fight, they went swimming, so they could have gone swimming again, or they could have had a water balloon fight. And so over here, listing all the possible outcomes. So swimming, swimming, swimming. I feel like I'm saying the same words over and over again, so I'm sorry about that. But they could have also done swimming, swimming, water balloon. So swimming, swimming, water balloon. Or this one would say they went swimming, water balloon, swimming. And then the next one would be swimming, water balloon, water balloon. So hopefully you can, I need to just make this a little wider here. So hopefully you can see that we're just kind of going through to list all of the possible outcomes. So that's what a tree diagram does, is it organizes all of your outcomes. So let's see. So they've gone swimming, swimming, swimming. That was the first one that we didn't have to put. Swimming, swimming, water, swimming, water, swimming, swimming, water, balloon, water, balloon. So now we're down here. We have water balloon, swimming. Or you could have done water, water, water balloon, water balloon, water balloon. Or you could have done water balloon, swimming, swimming. Or water balloon, swimming, water balloon. And let me move my face here so you can see. So you'll see that there are 1, 2, 3, 4, 5, 6, 7, 8 possible ways that Cousin Camp could have gone. You could also see those right here. How many ever places there are at the end of the tree, that's how many outcomes there are. So list all possible outcomes where exactly 2 days of swimming took place. So only 2 days of swimming. So it would be SSW, SWS. Here, I'm going to highlight them so we can see what we're doing here. So that has 2 days of swimming. That has 2 days of swimming. This one only has 1. That has 1. That has 0. This has 2 days of swimming. And then we have all of these down here. And then the one that we didn't have to worry about, it had 3 days of swimming. So it doesn't count for this anyway. So how many outcomes are there? Well, there was 1, 2, 3. There are 3 that give us what we want. So the probability would be a 3 out of 8. And then, so the probability of swimming twice. There we go. That way we have what we just solved for. I'm going to shrink that. I'm not going to be picky if yours runs into it, but. And then finally, there are 8 possible outcomes for all 3 days. Are they all equally as likely? The way that we did it, absolutely. They're all equally as likely. So, yeah, because they're just flipping a coin to say if it's swimming or a water balloon. So yes, because flipping a coin is an independent event. I misspelled independent event. There you go. Those are our notes. Sorry they were so long today, but now, like I said, we should be set to continue to practice. Come back and check these examples to help as we move forward. Thanks.